the title of my presentation was inspired by an interview in an important Italian journal during the COVID pandemics. And here, an immunologist, member of the scientific and technical committee advising the Italian government about what to do, said Italian science must apologize. It was not able to speak with a single voice. Now, in contrast, I would say, you have David Spiegelhalter, who was also a member of scientific technical committee advising, in this case, the British government about what to do, which has a totally different perspective. And he argues that how can you follow the science if it doesn't tell you what to do? And the idea is that the impression that if you know the science, you know what to do. Now, I think that everybody who has been through the pandemic will find a lot of statements in different places of the world of people and scientists and experts and so on with different opinions about the subject. Now, that raises two questions, which I will not answer, but I will leave it to you to think, or three questions. The first is, can science talk with one voice? The second is, should science speak with one voice? And the third is, if you know the science, you know what to do. Now, when this type of things happen, everybody's surprised. The public is surprised, politicians are surprised, managers are surprised, and scientists are surprised. Well, I was not surprised. Why? Because during the 80s, we participated in research about the links between emissions from Sellafield reprocessing plant in Cumbria and child clusters of child leukemia. Okay, and here, if you want, you can see the results of that research, and in this book by Sally McGill. The thing is that this type of controversy, as it is in the mentioned, also has some similar characteristics to the pandemics, the COVID pandemics. In that case also, and we are talking about the 80s, well, there was also debates and disagreements among modelers, epidemiologists, and doctors, medical doctors. And it was not only across the disciplinary boundaries, but also inside, meaning epidemiologists argue among themselves, modelers argue among themselves, and doctors argue about themselves. As it is the case in many cases in the UK, there was a commission of inquiry to come with a conclusion about this issue. And what is interesting, I think it was called the Black Report. And the result, the conclusion of that inquiry was not proven, meaning not that there was or there wasn't a link between emissions and the clusters of child leukemia, but that science was unable to establish one or the other. And again, at that time, people were surprised. Okay, but we are not surprised, not even in the 80s. And this has to do with, during the 70s, nuclear scientists at Oak Ridge published a paper, and then it was reproduced and discussed. And you can see here it distinguishing between science and transscience. The presentation I told Micah he can distribute among yourselves, and of course, if you want to, go further, you can even write to me and I will give you more details, but here you have the elements. So, and it was a problem almost similar to the one on Sellafield, but this was just the question that Alvin Weinberg investigated was, can science with a certain degree of reliability is prove or disprove that there is a link between emissions from a nuclear power station working normally. We are not talking accidents like in 3 Mile Island or Fukushima. We are talking about environmental and health damages. And he comes to the conclusion that science cannot do that. And he calls this type of problems trans-scientific, meaning you are in the realm of trans-science when you have a practical political problem that can be expressed scientifically, but science cannot solve. Now, as you can see, there were a lot of discussions about the terms, but it became clear that there were a number of problems that were them or called scientific, but in really science could not resolve them. And here, for example, it mentions all those simulation models, okay? And they argue here, for example, Harvey Brooks argued that you have a lot of simulation models, for example, to decide on energy policy, which are complex. And therefore, we know that those problems cannot be solved or deterministic, and therefore they have inconclusive. Okay, and we can go further into the argument. Now, what is the issue here? And the question is what I can call the problem-solving model of the modern state. So suppose you have a practical political problem and you want to solve it. What do? You translate it into a technical scientific problem, you solve the technical scientific problem, and you consider that the societal, practical, political problem has been solved. Now, from where does it come? Well, this model worked quite well during the modern times. And the assumption is that problems, societal and scientific, are simple or complicated, meaning that there's somehow a one-to-one relation between the practical problem and the technical problem. Now, from where does it come? Well, I think Galileo Galilei explains that very well. And it has to do with two types of externalizations. The first, you consider that the system you are studying is independent from its context. So that is this rather stable, and that the relation between the system and the study and its context is not important. And the second is the externalization of our bodies. So, meaning our personas have to be also removed from the system and the study. Therefore, and here Galileo explains this quite well, so everything that comes through our senses becomes what he called secondary qualities. And these secondary qualities are not important when you do science. Okay, now, time goes by and things start to change. So during the 20th century and even starting with Poincaré at the beginning of the 20th century, this idea that there are problems that are not simple or complicated, but rather complex. And here I like this quote from Heisenberg, who, do you know, is the one who formulated the indeterminacy principle. And he argues that what we observe is not nature itself, that nature exposed to our method of questioning. The idea is that you might have different methods of questioning nature, okay? And that will produce different type of observations, data, and research and analysis. Now, with time, this has been maturing, and then Robert Rosen, who is a mathematical biologist, proposed a definition that we followed about what does it mean that a problem or a system is complex. It doesn't, it's not about quantity, but it is about quality. And it is essentially about ambiguity. The idea that you need, in order to understand or study those a multiplicity of modes of description of the system. In other words, what you have is a plurality of legitimate perspectives that cannot be reduced one to the other. Okay. Now, going back to what I called the problem-solving strategy of the modern state, how does it look now? You no longer have a one-to-one relation between the practical problem and the technical problem, but the practical problem is complex, and therefore there is a plurality of perspectives about the nature and definitions of the question, practical political problem, and also there is a plurality of ways of describing the problem from a technical and scientific point of view. And now the question becomes, as it is no longer a one-to-one relation, but many-to-many, is who decides which is the practical political problem and who decides what is the technical scientific problem to solve. It's clear. We can go back if you need, but anyway, that's what we see when you are in that situation is that there starts to appear some really pathological situations. Those who in the UK will remember this famous photograph of a minister feeding his daughter with British beef just to prove that it was safe. And again, later in Fukushima, you could see Japanese ministers eating sushi from the waters of Fukushima to show that it was safe. So you create this type of problems that were not envisaged when you were reducing one problem political to one problem practical. Okay? And what you see also is that the hypothesis that in order to do science, you have to separate the fact, meaning primary qualities in terms of Galileo, from secondary qualities, our senses, is no longer credible. Just to follow, you might have situations like this, when you call a scientific committee like expert committee, like we saw with COVID and other cases. You have a practical problem, you call a scientific committee what to do. And you see that even what we consider a simple problem, which is quality of clean air or what is clean air, the panel or the committee arrived to conclusion that there are high uncertainties. And this is the interesting what it is in red, is it comes to the conclusion that in reality uncertainty is not a scientific problem, but a policy question. Why it's not a scientific problem? Because, well, science has uncertainty. More than uncertainty, there is ignorance. And each discipline, if person working on any research knows that there is uncertainty and there is a way to handle that. Micah mentions our book of 1990 on uncertainty and quality and things of that kind. The question is, how much uncertainty can a society tolerate? So it's about uncertainty toleration. And that follows with the idea that because uncertainty is always present, you can actually create uncertainty. And in order, for example, to promote a certain regulation or to oppose it. So substantially, what you have is that uncertainty, following the others, has been politicized. And you can say that today, in my way, I started to work on uncertainty and science at the early 1980s. And with time, we saw that uncertainty, everybody learned how to play the uncertainty game in order to follow certain political agendas. Now, not only that, what we saw is that because of the inability of traditional modern science to deal with some problem that community faced, we saw the emergence of what it was called at the beginning popular epidemiology, meaning people in communities developing their own expertise, helped with some scientists in order to address problems that institutional experts and managers couldn't solve or were not only were not able, so didn't see even the problem. Here is a classical case, one of the beginning of popular epidemiology, which has to do with Love Canal and the beginning of, as I say, popular epidemiology that today developed into what we can call the different styles of citizen science. Now, looking at this type of problems, during the 80s, we developed what we called a post-normal science. And when I say we, I'm referring to my friend and colleague Jerry Ravitz. And the idea is that what are the features, characteristics of this type of policy problems that have somehow some scientific element, but they are not the kind of problems that fit Galileo's idea of modern science. Now, the idea that facts are uncertain, and we call this the mantra of post-normal science, that values are in dispute, that stakes are high, and decisions are urgent. And I think that if you look at your experience in many fields, you will see that you can put concrete examples in each of these features of the mantra. In this, in a sense, disputes the separation between facts and values, which is a fundamental element in what it is called comitology. What expert committees do. They have to concentrate on facts and not of values. I had a student who participated in an expert committee on genetically modified organisms, and she asked the question, can we talk about two things? The first is, do we need them? And second, who benefits? And the chair said, those are not legitimate questions. And we don't like it, but he was correct in the sense that the expert committee concentrate on questions of facts, and therefore, for example, on questions of risks, as we saw before, and not on value questions about is that beneficial, who are the losers, who are the winners, and all the rest. Post-normal science has, I'm not going into it, you can look at the references. Substantially, we can say that it's a couple of insights that have to do with the mantra and also with the idea that when systems uncertainty or decisions takes off, the political practical problem go up, the community that evaluates quality extends. So we argue that we are in the realm of post-normal science, meaning high systems uncertainty or high decisions takes. Truth is not an achievable idea. But we say that we can then evaluate quality, and meaning and quality we can define as fitness for purpose. How good is a certain knowledge input and process in relation to a purpose? And again, here, who defines the question? The purpose. And here again becomes a question where all of us, community of people affected or interested in the problem, are part of this extended peer community. We can come back to this, but substantially, in a nutshell, this is the issue. Now, what we saw is that not only COVID had all these characteristic of features of the mantra. You can say climate change, ecosystems collapse, biodiversity loss, sustainability transitions have these features that we call post-normal characteristics, in which facts are uncertain, values are plural and usually in conflict, stakes are potentially high, and decisions are urgent. Now, not only that, on one hand, what we have is that the two premises of modern science, what I call the externalization of our personas and of the context, are no longer credible, and therefore I believe they are no longer legitimate, in spite that our institutions and constitutions and modern science continues to be inside that idea, an ideal. So what is the context, therefore, in which we have these new post-normal problems? Well, the first is that we are living through intolerable inequalities, social, economic, etc. That we are living through a period of weak democratic institutions, that there are increasing authoritarian tendencies, and also that there is this magical idea about the role of science in society. Now, and I am almost finished, for a long time, the idea that, well, we should do interdisciplinarity or multidisciplinary pull together is what it was called the orchestration of disciplines. But I think we learned during the COVID pandemics and other type of problems that science doesn't speak with one voice. Well, what we still haven't learned and is that knowledge doesn't speak only the language of science, and therefore the challenge we face is how do we create what I call choreographies of knowledge. And now, I believe that uh, all the gloom and doom around the polycrisis we are living through is just not good. And the only thing that creates among researchers and students is depression. So we have to say that there is a lot that we can do, things we haven't tried before, or we haven't tried it seriously. And coming from where I come and from our perspective, I can suggest a couple of tasks that are important today. And in a sense, they fit somehow with what the previous speaker was talking about. And it is the first is we should try to explore and test different ways of integrating sources and sorts of knowledge, knowing quite well that the integrated resulting knowledge will be temporal, provisional, it will be contradictory and even paradoxical. The second task is to explore and test institutional and constitutional arrangements that will be able to incorporate that integrated knowledge and know well that this new type of institutional constitutional arrangements might fail, we might have mistakes, but these failures and mistakes will be done with credibility and legitimacy. Well, again, thank you very much for the invitation, and if there are questions, I will be pleased to try to answer them. Thank you.